like we're strictly looking at the blank copy now. Like if you want to have the answer solution next to you so we can see how it goes, but we're going to be like walking through these questions, focusing mainly on the ones that almost all of us got wrong. Does that sound good? So you guys can pull out the blank copy, get your pencils, and let's get rolling. Chatting ladies in the back, we don't want that. Chatting.
I don't want the other packet, but I had it.
That's like the third time you've done that. All right. This first question, we did not like this topic. I remember I taught this one. I did not feel very good after I taught it to you guys because I feel like I didn't explain it very well. So we're going to look at this again. There are some people who did get this right. So if you did get it right, like still try to pay attention. You guys can help us walk through these answers. We'll do it together. All right. So this first question, what is the measure of the smaller angle below? James, what are we looking for in this question?
Smaller. I mean bigger.
No. What is the measure of the smaller angle, right?
Oh, yeah.
So we're looking for the small angle. So we do need to find x, but that's not the angle, so we're trying to find the bigger angle. Cool. What type of angles are these? Do we need to do a little review of angles? I think that would be kind of helpful. I know we have those up there. You guys might have done it earlier too, but just show me you guys know what's up. Parallel lines, right? And what is this one called? John? Transversal. Cool. So we have this transversal. Awesome. Now, I'm going to label them A, B, C, D, E, F. Cool. Angle A and B, Caleb. And are these congruent or supplementary? And if they're congruent, tell me which type. Don't yell out the answer. Or supplementary. Awesome. Perfect. D and E. D and E. Let's see. Maya. D and E. What type of angles are these? Are they supplementary or congruent? And what type of congruent angles are they? D and E. What type of angle? D and E right here. Are they supplementary? No. So they're congruent. What type of congruent angles are they? Yep, alternate interior. They're on the opposite sides of this transversal and they're within the parallel lines. Cool. Let's see. Angle B and angle F. Kenyon, B and F. Corresponding? Yep, cool. So now G and D. Here's D. Here's G. Anyone know this one? Supplementary or congruent? When you say congruent, you say supplementary? Who thinks it's congruent? Thumbs up. Who thinks it's supplementary? Thumbs up. Where are all the thumbs? Or do we just not know either way? Thumbs up for supplementary? Okay, so this is how I would do it. I would check first for congruence, and I don't recognize that this one's on the inside, so I would check for interior, but this one's not on the inside. So I don't know, they're not corresponding, they're on the same spot. So what I would do is I would move this G from this parallel line to this parallel line. Do you see how I moved it from that spot to that spot? How it's the same G, if that's this parallel line. I move it up to that one. It's just the same, it's in the same spot. And when they're right, and when two angles are next to each other, what are they? Congruent or supplementary? Supplementary. Awesome. Okay. I think you guys get that. So let's do this problem very quickly. So looking at this first problem, a lot of you set them equal to each other. Why is that wrong? Because they're not equal. And Alondra, what type of angles are these? Supplementary. So what does that mean we do?
We add the like terms.
We what?
We add the like terms.
Well, what type of equation? Do we set them equal? Yep, good. We add them up to 180. So we have this first angle and the second angle and add this into 180. So make sure we're writing this in our test, because I think only like 3 people got this question right. So we have our first angle, 20x plus 5 and 24x minus 1. Like Alondra said, we're combining like terms. So we have 44x, because these are the like terms. We combine the x's, and then we combine the numbers. And 5 minus 1 is 4. So 44x minus 4 equals 180. Inverse operations, get the numbers on the same side. 44x equals 1. Here. Oh, I'm subtracting. Wait. What do I do?
You minus 4 from
Oh.
180 at 170.
Yeah, no, I wrote
Yeah.
minus. Okay. So 180 minus 4, 176. We're dividing, inverse operations, 44. And x equals 4. So, D, are we done now that we found x equals 4? No, what do I need to do? What are we looking for in the question? What is it asking?
Again.
So here, what did he say? You can understand that,
I
Gil.
didn't
Understand it? So we know x, and the question is asking us for the smaller angle. Maya, what do I do next? When x equals 4 and I'm looking for the smaller angle.
Oh, you plug x right in.
Yep, you substitute, remember? So we know that those are equal to the angles, but we don't like those x's, so we gotta make them numbers. But we don't know which one's smaller. We can't just look at it from the picture. The picture could lie, right, Kenyon? Can't just look at it from the picture. So we have to substitute.
I got it right.
I know you got it right, but I'm just saying sometimes you like looking at things just in terms of the picture.
The one that looked at that got right.
I know. You're not always gonna be like that. 20 times x when x is 4. 20 times 4. Someone yell it out, please. 80. 80 plus 5. 85. 24 times 4. I had to do this one.
96.
96. Minus 1.
95.
Which one is smaller?
85.
So the smaller angle is 20x plus 5, and its measure is 85 degrees. So when you get problems like this, when you see parallel lines and transversals, first, and every single time, you have to figure out if the angles are congruent and supplementary. And that entails knowing when angles are congruent. And that pretty much means you guys have to study this. I think you guys have this in a lot of your sheets.
Might help if you want to look at it. You can see how it shows like these two are supplementary, the rest are permanent. Sometimes interior seems to exterior are supplementary, and it shows an example.
Okay, yeah. So you guys know all the congruent ones. The problem that we just did is what's called same side interior, because they're on the same side and they're on the inside. That means they're supplementary. This is pretty much just memorizing these vocab, honestly. And then same side exterior, those are also supplementary. So to be congruent, they have to be opposite and on the inside, or opposite and on the outside. And if they're on the same side on the inside or the outside, they're supplementary. But do whatever you guys need to do to think about this in a way that helps you. I like moving the angle up to the parallel line, replacing things. That really helps me. Were we all able to copy this down? Got this? Are we looking ahead? Cool, all right. So number 2, you guys are really good at doing like solving for algebraic expressions, but this one kind of stumped us because there were 2 variables. And I think it's a lot easier than you think. I think half of us got it right and half of us got it wrong. So number 2, 7m plus n equals 2. If we're solving for n, Caleb, what would I do first here? Do what? Well, remember in these type, we put our posters outside, but we check for distributive property, there's nothing. Combine like terms, right? Here there's nothing we can combine because these are variables, but they're different. And then, what was the thing? Inverse operations, which we need to do to isolate the variable. So, Caleb, what's our variable? n. And if we want to get n alone, we don't want it on both sides, do we? We just want it on one side. So what do I need to do to get n by itself? Yeah, this, right? We want this to stay on this side because it's already over here. We got to get rid of this. If this was just 7 plus n equals 2, you guys would know right away, right, to move this 7. The only thing different is that there's this m over here. So we just got to subtract the 7m. You can leave it like that. Minus 7m. And you can't combine these, but you just write it straight up like this. And that's your answer. There's nothing more you can do unless you're given n to make this easier. So write that down if you didn't get it right on your test. So we went through 3 and 4. We talked about the angle pairs. Check your answer solutions if you got that wrong. So number 5, can you look at number 5 quickly? We're going to talk through this one. When two angles are next to each other, Evelyn, congruent or supplementary? Number 5. Supplementary. Right? Is that what you said? Supplementary. So what would you do to solve for x? Yep, she said to add them up to 180. And then that's just solving using the algebraic steps we did. And you should get x equals 23. We're not going to go through that one because there's other concepts we need to focus on. We can always go back to it if anyone has any questions, mark it down. All right, number 7. This is an equation that you would be given. I learned that thanks to Maya. The interior angle sum formula, n minus 2 times 180. Chevelle, what is n? Number of sides, right? Do you remember this equation? Okay, so this we use when we have all different types of shapes. It could be a triangle, quadrilaterals, could be anything. So when we have, say, a triangle, how many sides are there? 3, so n would be 3, right? And for 4, what would n be? What did I just say for 4? For square, n would be 4. So, in number 7, this hexagon has how many sides? 6. So you just plug in for n. 4 times 180 equals 720. So this one is just substituting. Substitute, substitute, substitute. And then this one killed me. Killed all of us. Number 8. What is the measure of the exterior angle of this shape? 360? Is that what you said? What did you say, 360? Yeah, you're correct. And why is that? Yes, all shapes and under all circumstances, their exterior angles add up to 360. So that is like a question you should be super excited about when you see it on the test, because all you have to do is write 360. See that word exterior angle sum? Automatically know it's 360. That's just like fact.
I answered that one right, but I got it wrong. How sad is that?
That is really sad.
I did the opposite.
Oh, so you did it the opposite way. So remember that in the interior of a shape, these angles can be like bigger than 360, they could be 720, which we just found, they could be 180 when it's a triangle, because we use this formula. But exterior, these little guys are always going to add up to 360.
Think about exterior starts with E, and easy starts with E. So it's really easy to just remember that, oh, it's equal 360.
Easy, easy, easy. Cool. So, now this one, assuming that it is a regular shape. Alondra, what does it mean when a shape is a regular shape? It's kind of hard to put in words, just... Yeah, all sides are equal, all angles are equal, right? So the regular is, it's a very just, everything should be the same. So all I have to do is find one side and one measurement. So if you know that the inside angles all add up to 720, and there are 6 angles, Bryn, what would you do? if the inside of the shape was 720, you know the angles added up to 720, and there are 6 angles on the inside, and you want to just find a measure of 1. Yeah? Good. So say there's 6 of us in the room and there's 720 cookies, and like I want the same number of cookies as the other 5. Like I don't want them getting more than me. Like we split it up evenly. We got to do 720 divided by 6.
Or gave mine away.
Well, you're really nice. I am not. I'm trying to steal here. But we're trying to keep everything equal. So 720 divided by 6. 720 divided by 6. So it's the angle measure, the total angle measure divided by the angles. That is how we find just one interior angle measure. Okay, now we're going through these fast, but if you hear anything, just jot down any notes. If I'm saying anything too quickly or you need me to stop, raise your hand. This is a review session. This whole block is review. And I know it may seem boring and you guys don't put your heads down, but like this is super important, and I think those scores should show you guys like how important it is to realize how important these questions are. Because you also have seen these before, so they're important. All right. Finding the measure of angle B, number 10. You guys almost all got this one correct. Why did you get this correct, John? Do you remember what you did for number 10? When you're finding one measure of the angle? Well, if you didn't, let's walk through this. Inside of the triangle, using our interior angle sum formula, m minus 2 times 180. Evelyn, what is the degree measure inside of a triangle? Like, what do the inside angles equal up to in a triangle? 180. So, do you remember? Did you get this right, Jordan? No? So that you know that all the insides equal 180. You add them up to equal 180, and that's how you can solve for x. So you would do, make sure you're writing this down. X plus 20 plus 4x plus 60 equals 180, because all 3 angles added up together should be 180. So we know this one, we know that one, we know that one. And then it's just solving an equation. We combine like terms, we do all that stuff. You would get 5x equals 100 after doing all those steps. And you know that x equals 20. But am I done when I know that x equals 20, Josh? Well, what's the question asking? Find the measure of angle B, right? And if angle B equals 4x, what do I do? If I know B equals 4x, and I know x equals 20. Yeah, 4 times 20. We substitute. So angle B is 80 degrees. See that? Oh, you did. Awesome. We're good on 11, 12, 13 was this one. And this ratio with area. So, number 13. Erica, can you read number 13 out loud to us?
2 rectangles have an area ratio of 25 to 121 centimeters squared. If a larger rectangle has a length of 22 centimeters, what is the length of the smaller rectangle?
Cool. So, I always draw pictures. When they don't give me a picture, I put a picture on there, because geometry pictures are super helpful, but sometimes don't tell you all the answers. You have to make sure you do the math using these pictures. So we are given the larger rectangle has a length of what, Brennan? Length equals 22. And in this case, length and width are equal. I know that we have a lot of the time when we do like these types of equations, the area of a rectangle is just like width times height. But in this case, we just used L instead. Same thing, doesn't change the fact that A equals length times height. Okay, so we know the length of the big one, and we know that the area is, what is that, 121 centimeters squared. We have no length for this one. That's what we're looking for, right? The smaller length of the rectangle. And we know that the area of the little one from the ratio is 25 centimeters squared. What do we notice about the units of area? They're squared. And so they're not the same as the units of the length, which is just 22 centimeters. So we have to make them like synonymous. We can't just try to do an equation with centimeters and centimeters squared because they're not going to be equal. So to do that, when we have 121 centimeters squared, what is the inverse operation of squared? Square root. So we can take the square roots of 121 and 25. Say that again? Question? You got it? So in the area, we have square. We got to get rid of that square. So we can take the square root of 121, and on your perfect square sheet, or using a calculator, you would see that it is 11. And what is the square root of 25? 5. So now we can set up a ratio because we have units that are in the same measure. So we can do big over little, right? James, what would be the big one? So yeah, we can do, no, that's a little. 11. 11 over small, what would small be? 5 equals big, which is 22. Yeah, big over little, right? We have to stay consistent. We can't switch from big over little to little over big. You're gonna get it wrong. So you said big was 22 over x. This is our ratio that now we can solve by doing what? Juan, do you remember, Juan? How we solve this? Cross multiply. So we get 110 equals 11x. 5 by 11. X equals 10, and that is our answer. That is the length of the little rectangle. If you got this wrong, you should be copying it down in your notes. I know you guys have it in your answer solutions taken onto the front of this page, but they're not fully, some of them aren't fully gone through. Cool, can we get our heads up, guys, back there? No, I'm sorry, this is not fun, but this is super important, this review.
You can see my eyes.
I can see your eyes, but Maya is sleeping, she's got to stand up. Cool, let's turn to question, which one are we going to do next? 14. What is the shape of a tire? Is that a square?
No, it's a circle.
Yeah.
It's a circle.
It's a circle, right? Well, some people were confused, I think. How do you drive with a square tire? That is my question. So we know it is a circle. Tires are circles. Got this big old circle. And D, what do they tell us in number 14?
Number 14.
Read that question. I know there's a lot of papers.
You want me to do it?
You got it.
Trouble needs a bicycle tire. This tire has a brick.
Circumference, that's our word we do not like.
113 inches, which is the diameter of this tire.
So circumference, what is the circumference equation for a circle?
Cherry pies are
Delicious.
delicious. There you go. No, cherry pies.
Yeah. C equals pi d.
There we go.
I think a lot of you wrote C equals pi r squared. That's the area. So now it's just super easy. You guys use 3.14 for your calculators that don't have pi for some reason. What is the d? What is the diameter? Caleb, what's the diameter? Look in the question. 14. Guys, let's follow along. I know a lot of you are doing pretty well on this, but we got to work through this together. 14. 14? No, but yeah, but we're just strictly looking at the question. We haven't done the question yet.
Oh, at a tire?
Yeah.
What are you talking about?
The diameter of the tire. We don't know it, right? It's asking us that. It says, what is the diameter of the tire? So we don't know. That's what we're trying to solve for. We don't know. What does it give us?
The tire.
It does give us a tire, but what number? Yes, and what is that number?
113.04.
Awesome. Now we can find the D. There. What do I do now? Divide by 3.14. And we get the diameter equal to, like he said, 36. This one's all about applying an equation. You're going to be given this equation. Having the ability to recognize what you are given and what you need is going to help you find the answer. Because if you plug in C as 113.04 into the diameter, you're going to get a pretty big tire. Pretty big tire. So, use your equations. You're going to be given these equations. Don't let all these words intimidate you guys. Just look for the numbers. Look for what we work on and what we know. Cool. Sleepy over there. If you're tired and you need to stand up, go ahead and stand up. I know this is tedious. This is our review problem session. You can't stand and sleep. All right.
Sleepwalk.
Number 15, you guys all did awesome on. Joanna can see. 16. This one got us 2 for some reason. So, let's see. Oh, yeah, can you read number 16? Can you read that? Why not? You don't want to?
I'm measuring,
Stay in the way. Keep going.
I'm measuring the door, and found the perimeter was 8 meters. I know the height is 3 meters tall. I was trying to find a place that will cover my whole door, especially that area of my poster. The door poster will be the same shape and size. Therefore, there are one to each other.
Awesome. So for some reason, people got confused on this one too. What do we know about congruence?
They're equal.
They're equal. They're not similar. The ratios aren't different. So this one is like really easy. Should be one you also should get very excited about. When you see congruent in any problem, you know that they're equal. The thing that got us was having to switch from finding a variable in the perimeter to be able to apply it to the area. So for this one, I have my door drawn. James, if I have the perimeter and I have the height, what's the equation for the rectangle perimeter? Do you remember?
Period.
No, perimeter.
What's wrong with that?
2 times height plus 2 times width. Because remember, we're adding up, perimeter is just adding up all the sides. So it's the height plus the height and the width plus the width. So 2h plus 2w. So you guys will be given that. So what am I given, James?
Perimeter?
Is what? 8. Do they give me the height, Josh? What's it? 3. And what's the width, Bryn? What's the width of this? Number 14? Or no, number 16? Yeah, we can't find it, right? So we don't know. So we don't know it. That's what we need. Because we know that the area of a rectangle is width times height. And in order to get area, which the question is asking for, we need width. We have the height already, so we're searching for W. 8 equals 6 plus 2W. Inverse operations, subtract the 6. 2 equals 2W, so W equals 1. Now what do I do with this, E? What do I do with this 1?
Minus 3.
Well, how'd you do that? So, we're looking for the area, right? And now we know the width.
So,
What if we know, what height did they give us?
The height is 3.
3. And we're looking for A, so we don't know that. And now we know W. What does W equal? What did we just solve for? So we just substitute into the other equation, right? So the area just equals 3. 3 meters cubed. Those units are important. How are we feeling about that one? Are we understanding that we're looking for two things in these types of questions? Not only are we looking for the area, but we also have to find one of the side lengths in order to get there. Questions like these. So when I see questions like these, I look at the question, and again, I ask myself, which I do with you guys every day, what is the goal? And to get to that goal, what steps do I need to do first? Those are how you have to attack those problems. And writing down the equations of any words you see. So when I read number 16, I see the word perimeter, and I see the word area. So I write down or make sure I have those equations, and then just plug and substitute in those variables. All right. We're almost done, guys. We are moving. Stay with me, you guys are doing great. All right, number 18. Circles. I don't like circles. I like triangles. Okay. So we have the circle that has all these inscribed angles in it. Do you remember what inscribed angles are? No? So inscribed angles, first I'm going to explain the central angle. So this right here is a central angle because it's drawn from the radius or the middle of the circle. What do we notice what's different about this one? Yeah, it's touching the side and it's drawn to another side. It's not from the center. So an inscribed angle is different from the central angle. So what we know about inscribed angles, you guys are going to have to, when we study for our test next week, we know that this arc measure here is 2 times bigger than this right here. That is something we just got to know. So if this is like, say, 5, so say x is 5, what does that mean our arc measure is? 10. Cool. So, if we know that fact, and we know that on this problem, they give us that the arc measure from P to U is 118 degrees, and this inside little angle in here, the inscribed angle, is 27 degrees. We're trying to find this here and this here. Using this fact that if this is x, this is 2x. We know 118, and we know that's 2 times the size of